So far, we've been using a constant acceleration of g equals 9.8 meters per second squared for all free fall problems. However, this acceleration is due to gravity, which is caused by the enormous mass of the Earth. The effect of gravity depends on how close to the Earth you are. Isaac Newton's law of universal gravity is an equation that puts gravitational force in terms of the masses of the objects involved and the distance between them. It looks like this. In this equation, m1 and m2 are the masses exerting gravitational force on each other. As you can see, the force is directly proportional to the mass. Double the mass, double the force. You'll also see r squared in the denominator. As a result, this is called an inverse square law. The force is inversely proportional to the square of the distance. Double the distance, quarter the force. Why is that exactly? Well, picture an area surrounding the Earth. The Earth's gravitational pull has to be spread out around this surface like butter on toast. Now expand that area so it's further away from the Earth's surface. The same gravitational force is now spread out over a larger area, and the area of this sphere increases with the square of the radius. So as you move away from the Earth, its gravity is getting spread out among an area which is increasing by r squared. At twice the distance, there's 4 times as much area for Earth to pull through. The last term, big G, is a constant that takes the masses in kilograms and the distance in meters, then scales the answer down to newtons, the unit of force. Here's the first thing you need to do. We already have a formula for the force of gravity, or weight. It's F equals mg. So if you just take a 10.2 kilogram object as an example, F equals mg says that the force of gravity is 10.2 kilograms times 9.8 meters per second squared, or 100 newtons. The other equation should give us the same answer, so what is the value of big G? Find the mass, just go online and look it up, of the Earth in kilograms for M1. Use 10.2 kilograms for M2, and find the radius online of the Earth for R. Make sure it's in meters. If this expression is 100 newtons, after all, that's the weight or the force of gravity of a 10.2 kilogram object on the surface of the Earth, find big G. Just plug all those numbers in, solve for big G so you get that number. All right, now that you have a value for big G, you can use Newton's law of gravity to find weight and gravitational acceleration on all kinds of planets and at all kinds of altitudes. First, let's do the rest of the solar system. Find the mass and the radius of these bodies in the solar system. You could probably find them online. You'll need these numbers again on Thursday, so don't lose them. Now that you have those numbers, use Newton's law to find the weight of a 75 kilogram person, that's about 165 pounds, on the surface of each body, and the acceleration from gravity. G is the weight divided by the mass. Once you find the weight, just divide it by the mass, and you've got G, the acceleration. You could use your own mass if you like. Just take your weight in pounds, divide that by 2.2, and that's your mass in kilograms, but I would never ask anyone to supply personal information like that for an assignment if they were not willing. So 75 kilograms is your standard, but if you're curious, go ahead and use your own mass. Anyway, you will need to refer to this table again on Wednesday.